take a look at number 16. We got x plus 3 over x plus 4 minus x minus 4 over x minus 3. Now this is adding or subtracting rational expressions. Our first step is to find the LCM of all the denominators. That's our least common denominator, and rewrite each fraction of that new denominator. Now, the first thing we do there is we factor all of our denominators. Now, there's no factoring to do here, so we're going to dive right into figuring out what our LCD is, which is the same as the LCM. Now, remember our steps for finding the LCM, LCD. We look at each factor, like I'm looking at the x plus 4. And I'm looking for the greatest number of x plus 4s in a single denominator. There's 1 here, there's none here, so our greatest number of x plus 4s in a single denominator is 1. Then I go to my next factor, the x minus 3, and I'm looking for the greatest number of x minus 3s in a single denominator. There's none here, there's 1 here, so our greatest number of x minus 3s is 1. And that would be our least common denominator. Now we're going to rewrite each fraction with that new denominator. Now let's look at our first fraction. We had an x plus 4, the x plus 4 is still there. The new item down below is the x minus 3. Whatever new item you put down below, you have to put up on top. The mathematical principle behind that is whatever you multiply by the denominator, you have to multiply by the numerator. Okay, let's look at our second fraction here. It had an x minus 3. That x minus 3 is still there. The new item down below is the x plus 4. So whatever new item we put down below, we also have to put up on top. Again, mathematical principle behind that is wherever you multiply by the denominator, you have to multiply by the numerator. Now these are conjugates, and if you recognize that, it can save you some step. But I'll go ahead and just FOIL them, multiply them together. X times x is x squared. X times negative 3 is negative 3x. 3 times x is 3x. 3 times negative 3 is negative 9 over our denominator. Minus x times x is x squared. X times 4 is 4x. Negative 4 times x is negative 4x. Negative 4 times 4 is negative 16 over our denominator. Now negative 3x plus 3x cancels. So we got x squared minus 9 over our denominator. Minus 4x minus 4x cancels. So we got x squared minus 16 over our denominator. Now conjugates. Conjugate means the first part's the same and the last part's the same. So we got x and x, 3 and 3, but the sign in the middle is different. Yeah, this is positive and this is a negative. Whenever you have conjugates, all you have to do is multiply your first parts together and your last parts. So x times x is x squared, 3 times negative 3 is negative 9. Okay, that was step 1. Step 2, since they have the same denominator now, we're going to merge these into a single fraction, so we're going to add or subtract top parts. Remember, if there's a minus out in front of your fraction, this is going to flip the sign of everything up on top. So this will flip the sign of the x squared and of the negative 16. So we get x squared minus 9 minus x squared plus 16 over our denominator. Now, no matter where you are in math, you should always simplify, combine like terms, combine numbers, so forth. X squared minus x squared drops away. Negative 9 plus 16 gives us 7 over our denominator. Now, we don't have to do any other steps here because obviously we can't factor the top. Bottom's already factored, but we can't cancel either, so that's our answer. Okay, let's take a look at number 17. So we got 2x squared over x squared minus 4 minus 1 over x plus 2. Well, they have the different denominators, so we're adding and subtracting rational expressions again. So we're going to have to figure out what our common denominator is. And we want to factor all of our denominators. Now x squared minus 4 is the difference of two squares. Two terms with minus in it tells us that. So I'll do it over here on the side. We're going to try to rewrite that as something squared minus something else squared. You ask yourself what times itself gives you each individual piece. Well, x times x gives us x squared, and 2 times 2 gives us 4. I'll label what's inside the first parentheses as f for first. I will label what's in the last set of parentheses as L for last. So we got f plus L times f minus L. Now everywhere there's an f in my formula, I'll put in x, and everywhere there's an L in my formula, I'll put in 2. So we got x plus 2 times x minus 2. Okay, so we got x plus 2, x minus 2. And now all of our denominators are factored. So let's figure out what our common denominator is and rewrite each fraction with that new denominator. Now I'll start with my first let me put these up here first. Okay. I'll start with my first factor, the x plus 2. And I'm looking for the greatest number of x plus 2's in a single denominator. There's one here, and there's one here. So the greatest number of x plus 2's in a single denominator is 1. We're not counting how many there are. We're looking for the greatest number in a single denominator. Then I go to my next factor, the x minus 2. And I'm looking for the greatest number of x minus 2's in a single denominator. There's one here and none here, so the greatest number of x minus 2's is 1. So that'll be our LCD, least common denominator. Now that does match the same steps as the LCM. You do something a little bit different with it. Okay, let's see what's changed. We got x plus 2, x plus 2. X minus 2, x minus 2. First fraction hasn't changed at all. Let's look at our second fraction. We had x plus 2 in our denominator. X plus 2 is still there, but the new item down below is the x minus 2. Now again, whatever we put down below, we have to put up on top. So we're going to have 2x squared over x plus 2, x minus 2, minus 1 times anything doesn't change it, so that just becomes x minus 2 over x plus 2, x minus 2. Well, they have the same denominator now, so we're ready to add or subtract top parts. Remember, if you have a minus out in front of your fraction, this is going to flip the sign of everything up on top. So flip the sign of the x and of the negative 2. So we're going to have 2x squared minus x plus 2. Now that was step 2. Now step 3 says factor the top, factor the bottom, and then our last step will be to cancel. But let's see if that'll factor. If it factors at all, it'll be with the key number. Reason why I say key number, because we got x squared, x, no x, and there's a number in front of our x squared. Now with the key number, we take the number at the beginning times the number at the end, ignoring signs. So I'll take 2 times 2, which gives us 4. Number at the beginning times the number at the end. We're going to come up with our 3 columns. P column, we list all products, give us 4. We got 1 times 4, 2 times 2. The S column, we might add them together. 1 plus 4 is 5, 2 plus 2 is 4. The difference column will subtract smaller from larger. 4 minus 1 is 3, 2 minus 2 is 0. Now, a number we're looking for is always a number in our middle term, which is the 1, the invisible 1 here. I don't have a 1 over my S and D column, which means that this will not factor, and this is our answer. We don't have to do step 3 or step 4. Okay, let's take a look at number 18. We've got negative 9 over x plus 1 plus 5x plus 32 over x squared plus 5x plus 4. Okay, now we're going to need to get a common denominator, and our first thing we need to do is factor all of our denominators. Now x plus 1 we can't do anything with, but this second denominator is the PSD. Because we got x squared x, no number in front of our x squared. I'll do it over here on the side. So I got x squared plus 5x plus 4. PSD, we take our number at the end, ignoring signs, so the 4. Then we create our 3 columns, P, S, and D. P column, we list all products, give us 4. We got 1 times 4, 2 times 2. S column, we add them together. 1 plus 4 is 5, 2 plus 2 is 4. Difference column, we subtract smaller from larger. 4 minus 1 is 3, 2 minus 2 is 0. And I know it's right up here, but I like to keep the problem self-contained. Number we're looking for is a number in the middle term, which is a 5, which is right here, which means I'm going to use 1 and 4. So I got x1 and x4. Now our larger number that we're using 1 and 4, so our larger one is the 4, will always be the same size as the middle term, which in this problem is a positive. Number I circled in the S column, S for same sign, so if this one's positive, this one has to be positive. So this becomes negative 9 over x plus 1 plus 5x plus 32 over x plus 1, x plus 4. Okay, let's figure out what our least common denominator is and then rewrite each fraction with that new denominator. We'll start with our first factor, the x plus 1. I'm looking for the greatest number of x plus 1s in a single denominator. There's 1 here, there's 1 here, so greatest number of x plus 1s in a single denominator is 1. I go to my next factor, the x plus 4, and I'm looking for the greatest number of x plus 4s in a single denominator. None here, 1 here, so the greatest number of x plus 4s is 1. So that would be our common denominator. Now our second fraction hasn't changed at all, so I'll go ahead and just write down the top part. But let's take a look at our first fraction. Had an x plus 1, the x plus 1 is still there. The new item down below is the x plus 4. Whatever new item you put down below, you also have to put up on top. Whatever you multiply by the denominator, you have to multiply by the numerator. Well, negative 9 times x is negative 9x. Negative 9 times 4 is negative 36 over our denominator. Plus 5x plus 32 over our denominator. Okay, step 2. Now that we got the same denominators, we can merge these together into a single fraction. So we're going to add or subtract top parts. So I got negative 9x minus 36 plus 5x plus 32. Now always you should combine together like terms. Negative 9x plus 5x is negative 4x. Negative 36 plus 32 is negative 4 over x plus 1, x plus 4. Okay, step 3. Factor the top, factor the bottom. Bottom should always be factored already, so you shouldn't have to worry about that. Top part I can factor out GCF. Is there, I can factor out a negative 4. They're both divisible by 4. My first term is negative. So that gives me x plus 1 over x plus 1 and x plus 4. Then our last step is to cancel. Here's an x plus 1, here's an x plus 1. So those are going to cancel. It's going to give us negative 4 over x plus 4. And that's our answer. Let me save this page. There we go. And take a look at the next problem. Number 19. We got y over 4x minus plus, let's try it again, x minus 3 over 3y. Now these are a little bit different. This is still adding, subtracting rational expressions, but they're a little bit simpler. So you don't have to do as much work on these. Let's look at the numbers first. 4 and 3. I'm thinking what my least common denominator would be if I had 4 and 3. Well, it'd be 12. Now for the x's. I'm looking for the greatest number of single x's in a single denominator. There's one x here, there's no x's here, so the greatest number of x's is 1. Now for our y. I'm looking for the greatest number of single y's in a single denominator. There's none here, there's 1 here, so it'd be 1. So 12xy would be our common denominator. Okay. Now look at this number first, in our first denominator, 4. You ask, what do you multiply by 4 to get 12? Well, you multiply by 3. So you have to multiply the top part by 3. Now it had an x, and that x is still there, but the new item down here is a y, so I have to put a y up on top. Now over here, I look at the number, the 3, and I ask myself, what do I multiply by 3 to get 12? And that'd be 4. Now the y was already down there, but we put an x down here, so you have to put an x up here. Again, whatever you multiply by the bottom, you have to multiply by the top. Y times 3y gives us 3y squared over 12xy plus distributive property, 4x times x is 4x squared. 4x times negative 3 is negative 12x over 12xy. Well, now that they have the same denominator, I'm going to merge these into a single fraction, adding and subtracting the top parts. So I'm going to have 3y squared plus 4x squared minus 12x. Now I could put that in standard form, but that's fine for our answer. Standard form requires you to pick a variable, and I'd probably pick x first, so I put 4x squared minus 12x plus 3y squared. It has to go from largest power of x down to smallest power of x. Number 20. We got y over 6x minus x plus 4 over 4x. Well, let's get our common denominator first. I look at the numbers, 6 and 4. I'm thinking, what would be my least common denominator of 6 and 4? Well, it'd be 12. Now, we're looking for the greatest number of x's in a single denominator. There's 1 here, there's 1 here, so the greatest number of x's is 1. So our least common denominator would be 12x. Okay, so I asked myself, this already had an x, so I'd stayed as is, but I asked myself, what do I multiply by 6 to get a 12? I'll multiply by 2. So you have to multiply the top part by 2. Now over here, I multiplied the bottom part by 3 to get to 12, so I have to multiply the top part by 3. And it already had an x, so I don't have to worry about that. Y times 2 is 2y over 12x minus distributive property. 3 times x is 3x. 3 times 4 is 12 over 12x. Now that they have the same denominator, then I want to add or subtract top parts. And remember, if there's a minus before the fraction, that's going to flip the sign of everything up on top. So flip the sign of the 3x and of the 12. So this becomes 2y minus 3x minus 12 over 12x. And that's our answer. And let me grab a drink here and then... Okay, so we got 21. X to the fourth over y squared over 2x squared over 3y squared. Now there's a shortcut to this one I'm going to ignore. I'll go ahead and tell you about it though, so if you study that technique, then you know it. But if you got a single fraction over a single fraction, you can take your bottom fraction, flip it, and multiply it times your top. only applies when you got a single fraction over a single fraction, which is why I don't like it. People don't always remember when to use it. The way I showed in class, or it's 100% of the time, is to get rid of a complex fraction, complex rational expression in this case, but to get rid of a complex fraction, you multiply everything by the LCM of all your inner denominators. Well, what in the world is my inner denominator? Y squared is, and the 3y squared is. So the LCM of those would be 3y squared. So I'll multiply that times the top part, times this fraction, and I multiply it times the bottom part. Why did I choose a y squared for an LCM? Well, I'm looking for the greatest number of y's in any single inner denominator. There's 2 here, there's 2 here, so the greatest number of y's is 2. And then since this had a 3, I had to put the 3 on there also. Well, the y squareds will cancel there. The y squareds will cancel here. And also the 3's will cancel down here. So, we're going to be left with, up on top we got 3x to the 4th over 2x squared. And we can simplify this fraction. Remember earlier on in the course we looked at how do you handle it when you got x to a power over x to a power. You subtract a smaller exponent from a larger one. So 4 minus 2 gives you 2. And we have x to that power where a larger exponent was, which is up on top. So we're going to have an x squared right here. And that's our answer. Okay, so let's look at 22. We got x plus 4 over 5x all over 5x minus 1 over 4x squared. This one you could again use that trick on because we got a single fraction over a single fraction, which means you can flip the fraction on the bottom, take reciprocal of it, multiply it times the top. I'm not going to do that. I like the one technique works 100% of the time. So I'm going to multiply top and bottom by the LCM of all my inner denominators. Well, here's an inner denominator, and here's an inner denominator. First off, let's look at the LCM of 5 and 4. Well, that'd be 20. Now for the x's, I'm looking for the greatest number of x's in a single inner denominator. There's 1 here, there's 2 here, so the greatest number of x's is 2. So our LCM is 20x squared. So I'll multiply that times the top part, and I'll multiply that times the bottom part. Okay, so we got 20 and 5, both divisible by 5. 20 divided by 5 is 4. 5 divided by 5 is 1. Here we got 2 x's, and here we got 1 x. That x will disappear, and those will disappear and leave us to single x here. 4 and 20, both divisible by 4. 20 divided by 4 is 5. 4 divided by 4 is 1. And that x squared cancels with that x squared. So let's write down what we have left. We have 4x times x plus 4 over 5 times 5x minus 1. Yeah. Now, we would want to simplify this. We'd factor the top, factor the bottom, which they've already factored. And nothing cancels, so this is actually our answer. Okay, 23. Two plus 3 over x over 4 minus 2 over x squared. Let's first identify our inner denominators. Here's our inner denominator, and here's our inner denominator. Now we will multiply everything by the LCM of all our inner denominators. I'm looking for the greatest number of x's in a single inner denominator. There's 1 here, there's 2 here, so the greatest number of x's is 2. So we're going to multiply everything by x squared. So we'll take x squared times 2 minus x squared times 3 over x over x squared times 4 minus x squared times 2 over x squared. Now when I say everything, I'm talking about, we're separated by pluses, minuses, and this big division symbol. So that's why I multiply by 2 separately and by this fraction. And why I multiply by this 4 and by this fraction. Well, x squared times 2 is 2x squared minus this x here cancels with one of these x's, leaves me an x here. So that's minus 3x over x squared times 4 is 4x squared. And down here, this x squared cancels that x squared, and we got a minus 2. Well, always we want to factor to see if we can simplify. And both the top and bottom have GCFs, so let's do that first. Top part I can factor out an x, and that gives us 2x minus 3. Bottom part I can factor out a 2, and that gives us 2x squared minus 1. Now 2x squared minus 1 looks like difference 2 squares, because there's 2 terms minusing it, but nothing times self gives you the 2, so we can't take that any further, and since nothing cancels, then that would be our answer. What problem was that? 23? Okay, so let's take a look at 24. Six over x minus 12 over x squared all over 1 over x minus 4 over x to the third. Okay, inner denominators. That's the inner denominator. This one is over on this side. The x is and this x is. So we're going to multiply everything by the LCM of all our inner denominators. So we're looking for the greatest number of x's in a single inner denominator. There's 1 here, there's 2 here, there's 1 here, there's 3 here. So greatest number of x's in a single inner denominator is 3. So we're going to take everything times x to the third. So we'll take it times 6 over x minus x to the third times 12 over x squared over x to the third times 1 over x minus x to the third times 4 over x to the third. Well, this x cancels one of these x's, so that's gone. Leaves us 1 here, and this leaves us 2 x's. Here I got 2 x's, here I got 3 x's, so those are gone. Leaves us 1 down there, and leaves us a single x up here. Here's 1 x, here's 3 x's, so that one's gone. Leaves us 1, and leaves us 2 x's here. And both of these are 3 x's, so those are both gone, and leaves us 1 there. Let's see what we have left. X squared times 6 is 6x squared minus 12 times x is 12x over x squared times 1 is x squared minus 4. Okay, now we want to see if something will simplify. This top part is GCF. They both are divisible by 6. They both have an x. This bottom part is dots. 2 terms and minus string it. Difference 2 squares. So I'll do that over here on the side. X squared minus 4. We try to write that as something squared minus something else squared. You ask yourself what times self gives you the x squared, and that's x. And you ask yourself what times self gives you the 4, and that's 2. Okay, so I'm going to take what's inside my first set of parentheses, and I'll add what's in my last, and I'll take what's inside my first and subtract what's in my last. Plug in my formula. So we're going to get x plus 2 and x minus 2. Okay, back up on top. We'll factor out a 6x, and that gives us x minus 2. And down below, we'll factor that as x plus 2, x minus 2. Well, remember, after we do that, then we want to cancel. Well, they both have an x minus 2, so those are going to cancel. And we got 6x over x plus 2. And that's our answer. And number 25. 3 over x plus 2 over x minus 6 times 3x minus 18 over x. Now you should be prepared when you run across in mathematics. If something looks a little bit different, it shouldn't freak you out. You follow the different methods you've learned, and you order operations. Order operations says no matter what, you do what's inside the parentheses. So we're going to focus on what's inside the parentheses. We don't even care about this here at the end yet. Okay, well inside the parentheses, we're going to add or subtract rational expressions. First thing we would do is we'd factor all of our denominators, but there's nothing to factor. So we'll jump straight to the finding out what our least common denominator is. I'll start with the x. I'm looking for the greatest number of x's in a single denominator. Now, when I say greatest number of x's, I'm talking about single x's. This x minus 6 is not considered an x. So here's one x, and here's no single x's here. So we'd have 1. Then I go to my next factor, the x minus 6. I'm looking for the greatest number of x minus 6's in a single denominator. There's none here, 1 here, so we'd have 1. So that'd be our common denominator. Okay, so let's see what the new item is. This had an x, the x is still there. The new item down below is the x minus 6. So whatever we put down there, we have to put up on top. In our second fraction, we had an x minus 6. That's still there. The new item down below is the x, so we have to put an x up here. Again, the mathematical principle behind that is wherever you multiply by the bottom, you have to multiply by the top. Numerator and denominator. Okay, 3x. 3 times x is 3x. 3 times negative 6 is negative 18. Over x times x minus 6 plus 2x over x times x minus 6 times 3x minus 18 over x. Now we have the same denominators. We want to add or subtract the top parts. So we got 3x minus 18 plus 2x over x times x minus 6 times 3x minus 18 over x. Well, 3x plus 2x is 5x. So we got 5x minus 18 over x times x minus 6 times 3x minus 18 over x. Okay, now we're going to multiply these. And remember, multiplying, double check all my numbers there. Didn't seem to come out very nice, did it? I guess everything's right. Okay. Remember, multiplying, what we're going to do is we're going to factor everything. Can't factor 5x minus 18. This is already factored. This, though, is GCF. So let's go ahead and factor that. So I got 5x minus 18 over x times x minus 6 times, GCF is 3, so I'll factor 3 out, and that gives us x minus 6 over x. Now we want to, after we factor everything, we want to cancel. Only guideline is one's on top and one's on the bottom, and they're the same. Here's an x minus 6, here's an x minus 6. So they're the same, one's on top, one's on the bottom. Now I might think this x and this x, but both of them are on the bottom. One of them has to be on the top. Actually, there's nothing left to cancel there, so I'll multiply top parts together. So I got 3 times 5x minus 18, and I'll multiply bottom parts together. X times x is x squared. Typically, you don't actually multiply that through up on top. You do on the bottom, because x times x you can simplify as just x squared. And that'd be your answer. Let me save that. Let's look at number 26. We got m squared minus 9 over m minus 3. Now the instructions say divide the polynomial in the numerator by the binomial in the denominator. I'm going to follow those instructions. I might be tempted to, this is a rational expression also, so I might be tempted to factor the top, factor the bottom, and see what can cancel. But since the instructions specifically say that, let me show the division. Because you can't always do that technique what I just talked about. So I get m minus 3, and then I'm going to have m squared plus 0m minus 9. Now, these are, both have to be in standard form. Standard form says from largest power down to smallest. So we got m to the first, no m. M squared, m, no m. So that fits. And you also have to put 0 placeholders for any missing powers. We didn't have an m here, so notice how I put a 0, 0m. Now we're going to look at the first term of each, decide what to put up on top. You ask yourself what times m gives you m squared, and that'd be m. Now whatever you put up on top, you multiply by what's on front. So we'll take m times m minus 3, which gives us m squared minus 3m. Now we're going to subtract that line, which means flip signs. So this becomes a negative, and this one becomes a positive. M squared minus m squared drops away. 0m plus 3m is 3m. And then I'll bring down the minus 9. And then we repeat the process. We look at the first term of each, decide what to put up on top. You ask yourself what times m gives you 3m, and that'd be 3. Whatever you put up on top, you multiply by what's out in front. So I'm going to take this 3 and multiply it times the m minus 3. 3 times m is 3m. 3 times negative 3 is negative 9. Now we're going to subtract that line, which means flip signs. So this becomes a negative, and this one becomes a positive. 3m minus 3m drops away. Negative 9 plus 9 is 0. And the m plus 3 then is our answer. Number 27. Let me grab a drink here. We got 2x squared plus 6 over x minus 1. And it gives us the same instructions. So I'm going to set it up. I got x minus 1 here. And then I got 2x squared. Notice we're missing the x, so I'm going to put a 0x, a 0 placeholder for it. Any missing powers, you always put a 0 placeholder. Now I'm going to take a look at the first term of each, decide what to put up on top. You ask yourself what times x gives you 2x squared, and that'd be 2x. Now whatever you put up on top, you're going to multiply by what's out in front. So we'll take 2x times x minus 1, which gives us 2x squared minus 2x. Now we're going to subtract that line, which means flip signs. So this becomes a negative, and this becomes a positive. 2x squared minus 2x squared drops away. 0x plus 2x is 2x, and then I'll bring down the plus 6. And we repeat the process. We take a look at the first term of each, decide what to put up on top. You ask yourself what times x gives you 2x, and that'd be 2. Whatever you put up on top, you're going to multiply by what's out in front. So take 2 times x minus 1, which gives us 2x minus 2. Now we're going to subtract that line, which means flip signs. So this becomes a negative, and this becomes a positive. 2x minus 2x drops away. 6 plus 2 is 8. Now remember what your degree is. Degree is your largest power of x. So if I ask myself what the degree of 8 is, well, it's 0. There is no x. If I ask myself what the degree of x minus 1 is, it's 1. Whenever the degree of whatever you have down here is less than what you're dividing by, this is your remainder, no matter what it looks like. So we're going to take our remainder, which is the 8, and put it over x minus 1, what we're dividing by. And that's our answer. Okay, 28. we got 4c squared minus 2c plus 9 over 2c minus 1. So I got 2c minus 1, and then 4c squared minus 2c plus 9. Again, we look at the first term of each, decide what to put up on top. So you ask yourself, what times 2c gives you 4c squared? And that'd be 2c. Now, whatever you put up on top, you can multiply by what's out in front. So I'll take 2c times c minus 1. And let's try it again. 2c times 2c minus 1. Okay, 2c times 2c is 4c squared. 2c times negative 1 is negative 2c. So we're going to have 4c squared minus 2c. Now we're going to subtract that line, which means flip signs. So this becomes a negative, this becomes a positive. 4c squared minus 4c squared drops away. Negative 2c plus 2c drops away, and then I'll bring down to 9. Now the degree of this 9 is 0, and the degree of the 2c minus 1 is 1. It's a different idea. We're asking ourselves, what's the largest power of c? Same concept, though. So we're going to take the remainder, which is 9, and put it over what we're dividing by. So our answer would be 2c plus 9 over 2c minus 1. Number 29. We got 2m plus 6m squared plus 4 over 1 plus 3m. Okay, as I write this down, I want to put them in standard form. Standard form says you go from largest power down to smallest. So I got 3m plus 1. And then inside here, I'm going to have 6m squared plus 2m plus 4. Again, largest power down to smallest. M squared, m, no m. M, no m. If it's not in standard form, you won't be able to do the division on many of the problems. Okay, so we'll take a look at the first term of each, decide what to put up on top. You ask yourself what times 3m gives you 6m squared, and that'd be 2m. Now, whatever you put up on top, you multiply by what's out in front. So we'll take 2m times 3m plus 1. 2m times 3m gives us 6m squared. 2m times 1 is 2m. Now we're going to subtract that line, which means we'll flip signs. So this positive becomes a negative, and this positive becomes a negative. Now 6m squared minus 6m squared drops away. 2m minus 2m drops away, and then we'll bring down to 4. And again, the degree of this is 1. The degree of 3m plus 1, or wait a minute, degree of 4 is 0. Degree of 3m plus 1 is 1. So this is our remainder. And we'll put our remainder over what we're dividing by. So 4 over 3m plus 1. It's interesting how that's coming out. Let me just double check that real quick. Yeah, that's right. It seemed weird to have two real nice ones like that in a row. Okay, m to the third plus 3m squared plus 4m minus 8 over m minus 1. And same instructions. So we got m minus 1, and then we got m to the third plus 3m squared plus 4m minus 8. This is already in the right form. It's in standard form. We're not missing any powers. So we'll just dive right in with our division. You take a look at the first term of each, decide what goes up on top. You ask yourself what times m gives you m to the third, and that'd be m squared. Whatever you put up on top, you multiply by what's out in front. So we'll take m squared times m minus 1, which gives us m to the third minus m squared. Okay, so we're going to subtract that line, which means flip signs. So this becomes negative, and this becomes positive. m to the third minus m to the third drops away. 3m squared plus m squared gives us 4m squared. And I'll go ahead and bring everything down. And we're going to take a look at the first term of each side, what to put up on top. We ask ourselves what times m gives us 4m squared, and that'd be 4m. Whatever we put up on top, we're going to multiply by what's out in front. So we'll take 4m times m minus 1, which gives us 4m squared minus 4m. Now we're going to subtract that line, which means flip signs. So this becomes negative, and this becomes positive. 4m squared minus 4m squared drops away. 4m plus 4m is 8m. And then I'll bring down the minus 8. And we repeat the process. We ask ourselves what times m gives us 8m, and that'd be 8. And again, whatever you put up on top, you multiply by what's out in front. So take 8 times m minus 1, which gives us 8m minus 8. Now we're going to subtract that line, which means flip signs. So this becomes negative, this becomes positive. 8m minus 8m drops away. Negative 8 plus 8 is 0. So this is our answer. Now let me double check that was the last problem. I think it was. Yes, that was the last one. So let me save this. There we go.